The route command will give us information about how Linux or Windows is going to handle traffic if it doesn't know what network the traffic is on. So usually route's pretty straightforward. Typically you have one default gateway, one Ethernet card, and that's it. And all the traffic that you send, if it's not on your on the same local network, it's always going to route to the same default gateway. But in theory, you can have multiple default gateways. You can have, if you have multiple Ethernet interfaces, each one can have its own default gateway. And Windows or Linux may not know which default gateway to use if you have more than one, unless you have a routing table that tells it what to do. So if you wanted to look at that routing table, you just type the route command in Linux, and it shows you the route command. I only have one Ethernet interface on this server, so everything's pretty much going to route through the same Ethernet interface. It's all going to go to the same default gateway, and you can see that from that list. It says the destination. If the destination is default, in other words, if the destination is anything, it's always going to go to Ethernet 0. On my Windows machine, I'll run the same command, but on Windows you have to do route print, and it will print your routes. So you do have to do that extra step to see your routing table in Windows. So you can see this one's a little more involved, but probably just because I have additional Ethernet interfaces on here. But the idea is the same. You can it's a little easier to see in Windows though. And you can kind of see that all these tools have different, slightly different interfaces in Windows versus Linux. But in Windows, it does show you the metric, so you can see that that if the network destination is anything going to anywhere, that's the first line under active routes. So it says IP version 4 routing table, active routes. The first line 000, which means anything to anywhere, is always going to go to gateway 192.168.1.1. And that is a metric of 25, which means that's the most preferred route. And then these other routes have a higher metric, so they're less preferred than the first one for any destination that meets that network mask and destination. So again, that's the route command. In Windows, if you just type the word route, it'll kind of remind you that you have to use the the modifier, the print, but it gives you all this information. It's sort of like the help file for the command. So some of these commands are print. You can add your own additional routes. You can delete a route, and you can change an existing route. So sometimes you want to modify these routing tables. So maybe you want to change the metric, or you want to add a default route or a persistent route. And by the way, you would use the -p command, and you can see it right here in the command line switches. P means that whenever your computer reboots, it'll apply that route. That way you don't lose that route, because every time your computer reboots, it rebuilds that routing table. It's all cached in memory, so it has to get rebooted each time, rebuilt each time you reboot. So -p is important to remember on some systems. So why would you want to do this? Why would you want to add your own routes? If you do have multiple default gateways, instead of letting Windows determine which is the most appropriate default gateway for a given network, you can force it to use one interface or the other, which is useful in servers when it's straddling multiple networks, and especially so in Linux. Although in Linux, routes kind of useful in Linux, but in practice, I think for the most part in Linux, if you're going to be using it for routing, you're probably going to use something like IP tables with IP chains, which we don't get into in this course, but is slightly more advanced than just using route to tell it how to route the traffic through each interface.